So here's our old friend PCI Express, which is what I heard you all using here. Why did this happen? Well, the PCI bus is a parallel bus, and as fast as we could clock it was 100 megahertz, and we finally reached a point where the bandwidth of that bus was not adequate to deal with the speed of processors that we now have. And so we replaced those parallel buses with point-to-point differential signaling, and that's what PCI Express is. The advantage of differential signaling is you get much higher bandwidth. The disadvantage is, because it's not a parallel bus, there has to be a switch chip to direct traffic between the different loads on the net. Well, early on, this was in Intel's case, the only PCs with PCI Express were the high-end ones the gamers use, because they were willing to pay the extra cost of that switch chip. But now the switch chip is built into the processor, so that is no longer an extra burden. And I think that all of the new processors from Intel and AMD are PCI Express, and the parallel bus is gone. And I have to tell you, I like that. And the reason is, if we take the basic PCI bus, it's 137 bits wide, I can replace that with 4 wires of differential pair. So the routing load on the board went down by 8 to 137. Nobody should be unhappy about that. I think that's a good thing. So anyway, what I've got here is just a summary of the versions and what their data rates are and what the clock frequency is and what kind of encoding they have and the bit period. Remember the skew conversation about 1/4 of a UI, which is what that is. You can see that when we get up to 16, it's a pretty small bit period. We can't tolerate very much skew at that data rate.